Hello and welcome to Noel's RetroLab. Today we're going to go back to the Amstrad PPC512 from last week. If you remember, we got it working, but the internal LCD just refused to work. So today I'm going to attempt to fix the LCD, do some light restoration, like there's some parts that are kind of broken, and then if we have time, I'll start on some of the much needed upgrades. So I'm going back to the LCD trying to figure out why we're not getting any image. And I looked in the circuit diagram a little bit at the connectors. And I saw something interesting, that apart from several signals that are going there, it is powered and there's ground, there's 5 volts, but there's also a minus 20 volts, which seems a little unusual. Obviously that needs to be generated from the 12 volt DC that we were feeding into the Amstrad. So I see that and I think, well, there's always the possibility that something is not generating that voltage correctly, and that would probably cause the LCD not to display anything at all like we're seeing. So it's worth checking those voltages. Let's see what we get. I'm going to start with the easy one. This should be 5 volts. Okay, 5.1, that's fine. And then this is supposed to be minus 20. We get minus 15, minus 15.5. Now there's usually a percentage of variation that you're allowed to, but that would be like 25%. So that might be it. That might be enough not to power the LCD. The Amstrad PPC has two types of power connectors. One of them has already plus 5 and plus 12 and all sorts of weird things. We're just fitting it plus 12 volts through the DC jack. From there, this complicated circuit generates another huge variety of voltages. Plus 12, plus 5, minus 5, minus 12, I believe, and minus 20 for the LCD. If we trace back the minus 20 output, one of the things we find right away is a voltage regulator. So when I was looking on the board for the different components, which by the way, it's pretty difficult to find the components on this board, especially because this is split 2 boards and the labels are so tiny and kind of spread apparently randomly. I did eventually find the voltage regulator, and supposedly it takes minus 30 volts and it outputs a stable minus 20 volts. So that would be the first place to check, I would think. But then I noticed a few interesting things like, what's up with this? Yeah, that looks like a total regular voltage regulator, like a 7805 or something, that's been cut. I don't know when that happened. I mean, I suppose it could even be from the factory. I don't know, I would have to check. I did look in the schematics, and this is actually a 7905, so it generates minus 5 volts. And on the diagram, it says it goes straight to the modem. So maybe this is not used at all, and it explains why things are working. Yeah, it's a little odd that it's like this, and if this is like this, it makes me wonder what else is going on, right? So we need to check that. There's one other thing that I noticed, and that's the DC jack connector. It seemed like sometimes I would plug it in and the computer wouldn't start, and then I would plug it in a slightly different way and it would. And then looking at it, it looks like it has a bad solder joint because I can move it. There, do you see that? That's a bad solder joint. It doesn't have much solder to start with. So I'll start fixing that, and then I'll check on the voltage of the minus 20 volt voltage regulator. Okay, now I try to move it and it stays solidly in place. So I shouldn't have that problem anymore. It's a little uncomfortable, but let's measure that voltage. So that one is minus 16. That's probably the one that we're seeing as 15 earlier. That's 0. And the middle one is 17. So yeah, from the data sheet, this is supposed to be about 30. And that makes sense because usually these kind of linear voltage regulator, the input needs to be at least 2 volts higher than the output. So it makes sense. It can't generate 20 when the input is minus 17. But so I guess it's mostly just letting it pass through with a slight drop in voltage. So this is really not doing anything because it's just not being powered correctly. So we need to trace this further back to see where those minus 30 volts are supposed to be coming from. Okay, so further up in the chain of voltage generation, there is a coil and a transistor, and the output of that gets sent to those two capacitors. So there should be some variation in the signal there in one end, and then on the other end, we should already be in the minus 30 volt range. So let's check it out. Okay, so that's the minus 15 with that pulse in there, and then on the other side, yeah, this is the output from that transistor and coil. So yeah, that should definitely be lower. That should be minus 30 with that pulse. Looking at the circuit, that could just mean that we have a big capacitor, which is this one over here, that is holding the voltage down. There's some diodes around it and all that, and then that's fed directly into our voltage regulator. So I wonder if it's something as simple as this big capacitor is just not holding the charge correctly. I mean, it's very steady, that's the only thing, but maybe it's just not holding the charge correctly, not all the way down to minus 30 like it's supposed to be, and that's what's causing the problem. When repairing things, it's a good idea to strike a balance between going after the most likely thing or spending a while trying to figure out exactly what's wrong and just trying something that is very easy to check. So if I suspect it could be related to this capacitor, it's really easy to pop it out and replace it with a new one. So before we get fancier with looking at the diodes and some of the other weird things, I'm just going to go ahead and pop it out and check it. If not, we can put it back in. It's just 2 leads. It should be very easy. Let's go ahead and measure the capacitance on the capacitor I just pulled out. And yes, I know this is not a very accurate way of measuring it, but it gives you a rough idea. Like if this is really bad, normally this will detect it. And this is a 63 volt, 100 microfarad. So we look in the table, 100 microfarad, 63 volts. And for this to be good, it needs to be lower than 0.3. And wow, check it out, it's 0.4 something. So it's, at least as far as this tester is concerned, this is beyond the range of being good. So this could be very likely the reason we're not getting all the way to minus 30 volts. So it turns out that 63 volts and 100 microfarads is not a very usual measurement for a capacitor, so I don't have any spare ones. So I pulled out this one from another Amstrad PPC, the donor one, that wasn't working. So I'm hoping it's not working because of this, but at least we can measure it and see if it's any different. So same thing, 63 volts, 100 microfarads. So this says is right on the edge, 0.3 something. So it looks like it's a little better than the other one, but probably not great. So we could try it, but we should definitely be replacing those, and maybe even considering replacing all the other ones. When one electrolytic capacitor is bad, there's a good chance that several others will have problems as well. But we have nothing to lose. Let's try this and see if we manage to get minus 30 volts, and hey, maybe that will fix the LCD. Okay, nothing exploded so far, so that's good. And let's measure that. And nope, it's still 15 with the ripple in there. Yeah, that should be as before. So we're probably only getting, yeah, we're only getting the 15 in there still. Okay, so that wasn't it. Time to keep looking. So another possibility is that the voltage regulator itself is somehow faulty and it's preventing the input voltage from charging up correctly. So I pulled it out, and before I just replace it with the equivalent one from the other machine, what I'm going to do is I'm going to check the voltages at the board. So I want to see if that input voltage, which is that middle pin right there, really builds up to be 30 volts, minus 30 volts, like it's supposed to. So let's check it. This is the input. Look at that, minus 29.5. That's close enough to minus 30. So that makes me think that, yeah, the voltage regulator itself may have a short inside or something. And it wasn't just a matter of not outputting the correct voltage, but it was even dropping the input voltage itself. So let's put the one from the other computer and see if that fixes it. So I tested it, and unfortunately nothing. Still 15 volts and nothing had changed. I kept looking around through the voltage generation circuitry and I couldn't find anything really wrong with it, at least just by looking at the circuit. And then I had another thought, which is we have this 7905 missing and it's not providing minus 5 volts. And supposedly that goes to the modem. But I'm looking at the schematic, it generates a bunch of different voltage levels, and I'm thinking that some of them feed off each other, so that maybe we're not getting minus 30 where we're supposed to be getting minus 30 because we don't have minus 5 in there. We're actually off by 10 volts, and this is very suspicious. Check this out. This is the input, so to that is minus 12, and then here we're supposed to be getting minus 5. But right now, in there, we have 8 or 9. You know, this is clearly not disconnected. There's something else driving it there. And so if we put minus 5 here, it's possible that then we would get 30 here. There we go, minus 30, I mean, instead of minus 17. We should really have this 7905. Let's put one in and see if that affects that. With the new voltage regulator, and let's turn this on. And let's first make sure that it is working. We should be getting minus 5. There we go. And what do we get? We get minus 20. So that was it. So the input to this one is probably minus 30. Yes. Okay, this is very interesting. Let's see if we get any kind of output on the LCD. Okay, let's test it and see if that was the problem. Okay, we still get that line, so that's not great. We're not getting anything. Oh no. We should have gotten a message in there by now, and there is absolutely nothing. I was convinced it was that minus 20 voltage that was the problem. What a bummer. Oh, oh no. The reason we're not seeing anything is because the contrast wheel was all the way down. You actually have to turn it a fair amount up, and there you go. It's perfect. Well, not this, but this is great. Now, before you feel that everything that we've done was wasted, I definitely tried this last time, messing with the wheel, one extreme and the other, and we were getting no image whatsoever. So we definitely, what we did is correct. We definitely needed to get those 20 volts into the LCD screen to see anything, but this is awesome. We're finally seeing some text. This is a pretty normal fault with LCDs from what I've seen, and it's something we may even be able to fix when we swap frames, which is probably what we're gonna do right now. So, woof, I'm really relieved to see this. Well, that took some effort, but we got the LCD working, so that's great. I guess the lesson learned here is that if you see a missing piece on the board, just replace it right away. Don't wait. We could have saved a little bit of trouble by doing that right away. So anyway, what I want to do now is replace the LCD. Take the frame that was in that computer because it's nice and white and all the hinges are working, and put the working LCD inside. And then at the same time, let's see if we can replace that ugly vertical line that we have. Let's start by taking the cracked LCD out. That way we can experiment with this one in case something goes wrong. So it looks like we just have some screws in the back. Oh, and it looks like it has a little tab in here. Actually looks like it has tabs there, there, and there. So maybe it's better to open it in here. Ah, there we go. Not sure exactly what I did, but it popped off. Without breaking, that's always good. Yeah, what a bummer how it's cracked. I wonder how that happened. And here's the good LCD. It looks to be in really good shape, so that's great. But before I put it in the case, I would like to have a look at it, see if we can fix that vertical line that we're getting. That usually happens because some of the connections get loose or don't make as good contact. At least that's what I've seen in other places. So I think I'm going to try to remove this metal frame and see what we find inside. And if so, try it out and see if we can do something about it. Okay, so it looks like the middle frame is just held together by tabs in the frame, twisted and holding the PCB in place and grounding it at the same time. This little, oh right, this little pad is to protect the ribbon cable from rubbing up against this and breaking eventually. Okay, that should be everything. There you go. It was just a little stuck. Wow, look at all those tiny connections. Each of those is probably a pixel. Wow. And this is where they all connect to the LCD right here. So I was hoping to be able to push into these contacts while we had it on, but because this is between the PCB and the frame, I don't think I could or should take this out. So we may not be able to do that. Oh, I see. So this is not just a rubber pad. This actually has this conductive strip in the middle, and that's where it makes contact with all those little pads on the board. So who knows? I mean, it could even be one of those little dirt bits that got in there, little dust. So maybe I should just clean those and put everything back together and see if we made it better or worse. Okay, so I've temporarily hooked it up. The keyboard is not hooked up, so maybe we'll get some different errors. Right now it's just to see if we get some video out. Okay, well, we still get video, but we still get that ugly column in there. Oh, and actually we're getting worse. You can tell there's some rows and columns that are not making good contact. So the missing lines and columns, those are probably just when I put it back, the screen is not making very good contact, so I need to reopen it and clean it well. But seeing that vertical black bar again, so noticeable. And if you notice, it wasn't just that one, but it had like a wider area that was slightly darker. It makes me wonder if it's a problem with the circuit back here. And if that's the case, I want to try putting the circuit from the broken board. At least that way we'll know if it's a problem with the board itself or with the LCD. So this is the LCD with the other back, with the other board. And let's turn it on and check it out. Look at that. That line is gone. Now the quality is really bad. They're missing bits. Yeah, that's pretty bad. So, but I think that's fixable. I think that's cleaning the edges well, which I didn't even try to do this time. How about pressure? So pressing doesn't seem to make any difference. So I suspect it's a matter of cleaning that well, but yeah, that line that we had in there and that whole big column, that's all gone. That's all working now. So this is definitely a step in the right direction. Let's see if we can fix that and get a perfect LCD again. So we need to clean those contacts really well and those over there. I think those are called zebra strips and they need to be fully conductive. I see some junk in there. So I'm going to use some contact cleaner for this already in a cotton swab. Yeah, it's coming out a little dirty. Okay, that's really clean. And for the zebra strips themselves, I'm just going to use some isopropyl alcohol, just because I know the contact cleaner has some of that, but I don't know what other products, what other chemicals it has. And I don't know how they will react with this. And this is just, maybe I can apply contact cleaner to this as well. Okay, so I think I see what's going on in here. If I manage to get the camera just right, you can see lots of little indentations where the connectors were previously resting for the last 30 years. And so I suspect those are not making good connection. One thing that might fix it, I don't know, is to take it out and flip it. It's bidirectional. and maybe that will push against the LCD, and that's good enough. And then the contacts, the PCB contacts, will be up against the flatter parts. To give it a little cleaning as well. Okay, let's try that again with the zebra connectors flipped. Wow, that is much better. I think we're missing one row in there. Yeah, much better. Oh, there we're missing some, and we're missing one in there. We're missing one at the top. So yeah, I'm not sure we can get much better than this. I suspect this is the part where the connector has been deformed, and those are the shape of the old pins, and they're not making good contact. So I mean, it's kind of usable here. It's better than it was before with that cracked screen, but it's not perfect. So I believe you can buy those zebra strips nowadays. So I'm gonna see if I can get new ones, because that might be the best way to fix it. For now, this is pretty decent. So let's put it back in the frame and see everything working together. Time for the final test. Let's try with the MS-DOS boot disk and everything. There you go, it's starting up. Yeah, that's totally readable. It's not perfect, but yeah. It's better than with that black column that I used to have. Oh, the ghosting in the screen is horrible. Ugh, that LCD is actually worse than I realized. I wonder how my Frankenstein game looks on this screen. Let's give it a try. Oh wow, it just doesn't work. So apparently the Amstrad PPC can emulate a CGA display on the MDA display of the LCD. Obviously the quality is not going to be the same, but at least you get something. It didn't work with my Frankenstein game, probably because the editor that I used wasn't fully compatible or something. I would like to see something else running here, so I'm going to try David's Planet X3, which I've seen working in a huge variety of platforms. So let's give that a try. It gives us some options of which video mode to start. We'll just choose plain CGA 320-200 with 4 colors, probably because it's the most compatible mode. And nothing again. We hear the cool music, but completely blank screen. So yeah, I was first thinking that I was going to do some upgrades to this LCD and put some kind of backlighting, but I'm not liking at all how limited it is, so I may have to look for a different option. Now that the LCD is working, it's time to give it a little cleanup. You didn't even notice that it got a little green from rubbing against the mat on my workbench, but hopefully all of this will come out with some generic cleaner. Much better. I noticed there is a small nick right there. So if at some point I decide to de-yellow the other case of the Amstrad, then I could swap those out. But yeah, this is pretty good for now. So this handle, I thought it would be missing the screw, but no, unfortunately the screw is there. It's just that whatever the screw was screwing on, some peg inside must have come loose. So I'm gonna take everything out and see what's happening there. I'm not sure I can remove anything from here. Oh, there you go. Right. So yeah, this peg, it came off. But this is pretty good. We may be able to glue this back together. There, I'm just applying some of that 2-component glue or epoxy or cement, whatever that's called. I just need to push it in together and leave it like that for about 24 hours. Usually this makes a really strong bond, so I think it's going to work. If you remember from earlier, this piece in the hinge is actually 2 parts and it was coming apart. And I thought I was going to have to put glue just like we did with the handle and leave it gluing overnight. But it turns out that it was just the keyboard piece was not set correctly. So I just adjusted the keyboard and then this is all working correctly and it opens up just fine. So that's great. So, okay, one less thing to worry about. So there's this hinge that doesn't stay put completely. And yeah, that's because it's missing a couple of parts of the hinge. You see that? The hinge is broken and then there's supposed to be another part in there that catches when you close it, just like in the other end, right there. Just like that one. So I don't have the part to glue there back together. And I'm even afraid of taking this out because I'm afraid that if I take it out, the hinge in some of the other spots is going to break. So I think the best course of action here is actually to just leave it alone and live with that imperfection. And if this ever breaks, I will, at that point, take it out, glue whatever breaks, and attempt to fix this and do something better. But for now, I think the likelihood of me making it worse than it is pretty high, so we're not going to do anything with this. So this is 24 hours later, and this looks pretty sturdy. So let's try gluing it back together and see if it holds the weight of the computer, although I probably shouldn't try to hold it completely by the handle, but at least it will look better. Oh yeah, look at the difference between what was the original color of the case and what it's now. So it's even a lighter cream than it is right now. So, but still, it looks pretty good. I'm not going to try to do any de-yellowing right now. There you go. That's great. And one last touch is the computer has some rubber feet on this side, probably intended to be put upright like a suitcase, and it's missing this one. Well, fortunately it's not missing, it just came off. So I'm just going to put some super glue and glue it back in place. And there's the final result. So much better than it was before. It took some work, but it was definitely worth it. And we're out of time. So we didn't get to the upgrades, but at least we managed to get the Amstrad PPC512 in much better shape. It's almost as good as you would have gotten it if you had bought it brand new in the store. This will be my last December video, but not the last video on the Amstrad PPC. I definitely want to do another one on the upgrades, but actually have a long list of ideas on things we can do to this computer to make it into an even more interesting early MS-DOS computer. Speaking of December, make sure you check out the playlist in the description below. There are lots of other videos by other members of the community, all about MS-DOS retro computers, and actually quite varied topics, so I really highly recommend it. This will also be my last video for this year. Looking back, it's amazing how much the channel has grown, way beyond my expectations. So thanks everybody for your support and your comments and your feedback. This would not be possible without all of you watching. I wish you all happy holidays, a much better 2021 than this year, and I will see you on the other side. If you enjoyed this video, please consider supporting Noel's Retro Lab on Patreon or joining the membership on YouTube. Not only is that the best way to support this channel and allow me to continue making more videos, but you also get some extra perks like early access, ad-free videos, and more. Thank you again to all the supporters. See you next time.